Hello, in this last video for chapter 9, we're going to talk about alkylation of alkynes, and then we're going to summarize all of the reactions from our alkynes chapter. So alkylation of alkynes is a really handy way to add any alkyl group really to the end of an alkyne. Now it does have to be a terminal alkyne. So alkylation of alkynes is a method used to add alkyl groups onto a terminal alkyne. Okay, so I'm just going to draw a generic terminal alkyne. So remember, R just symbolizes some alkyl group. And then we need to first deprotonate the alkyne. So we need to remove that hydrogen so that we can then add something onto that carbon. So we're going to use a strong base, and similar to our preparation of alkynes, we can use sodium amide. But really any super strong base will work. And then that's going to leave us with the acetylide ion. Oh, I misspelled that. Acetylide, there we go. Acetylide, however you want to pronounce it. Now, in that process, we're also going to form ammonia because, remember, the NH2 has two lone pairs. So one of those lone pairs will grab the hydrogen, and the shared electrons are left over on the carbon. Now, there is one stipulation here. The conjugate acid of the strong base has to have a pKa greater than 25. Now, the terminal alkyne has a pKa equal to 25. So what we're really trying to prevent here is the acetylide ion reprotonating itself. So let's just make a note. You must use a strong base whose conjugate acid has a pKa greater than 25. So NaNH2 is a good option. Its conjugate acid does have a pKa greater than 25. Okay, so now how do we add an alkyl group onto the triple bond? So we're going to use an alkyl halide. So let's use a simple alkyl halide. And we're going to perform substitution. So the negative charge, or the lone pair on carbon in our acetylide ion, is going to be attracted to the partial positive charge on the carbon next to the leaving group on the alkyl halide. And then the leaving group will leave. So this is SN2. Now, we do want to use a primary or methyl alkyl halide. So we don't want it to be secondary or tertiary because otherwise we're going to have an E2 reaction because the acetylide ion could take a proton instead. So we want to favor substitution, not elimination. So let's just make a note of that as well. So we must use a primary or methyl alkyl halide because secondary or tertiary will favor E2. Okay, so now in our last bit here, we're just going to draw the product. So our acetylide ion has now bonded to that ethyl group. And I'll just highlight that for you so you can kind of see what we added on there. And then, of course, we still have our bromide ion hanging around from the alkyl halide. So you can probably imagine that this is going to be really useful for synthesis problems because we can kind of create whatever type of alkyne we want to so that we have the groups that we want on either side. And then we can move on from there. So this is going to be super useful in the future. Now, what if we have the simplest alkyne, acetylene? So remember, acetylene has a hydrogen on either side of the triple bond. So potentially, we could replace both of those hydrogens with alkyl groups of our choosing, as long as they're not, secondary or tertiary alkyl groups. So what we would do in that instance is we would first use NH2, so sodium amide, to remove one of the hydrogens. And then we would add an alkyl halide. So I'm just going to draw the one that we used on the last slide, but you can use any alkyl halide as long as it's primary or a methyl alkyl halide. Then we're going to do that again for the other side. So in the third step, we'll add more sodium amide to remove the other proton. And in the last step, we'll add whatever alkyl halide we want, as long as it's primary or methyl. And that will give us the following product. So we'll have an ethyl group on either side of the triple bond. Now let's look at this step by step just to make sure we understand what's going on here. So we're starting with acetylene. And in the first step, we add sodium amide. And again, that's going to take one of the hydrogens. So we end up with our ion. And then we add our first alkyl halide. So that's going to add to the right-hand carbon because I arbitrarily chose that one to lose a hydrogen from. But either side works. You could start with the left side too. And then in the next step, we're going to add more sodium amide. And that's going to remove the other hydrogen. So we get our negatively charged carbon again. Then we add another alkyl halide. And that gives us our final product. I should make my arrow longer, I guess. Makes it look like I just kind of skipped ahead. Okay, so NaNH2, just as a note, deprotonates one hydrogen at a time. All right, so again, this is going to be super useful when we start doing more synthesis problems because you can kind of make whatever triple bond molecule you want, and then you can go from there. So you can imagine, let's say you have to create a 6-membered chain, so a 6-carbon chain, and you just have an alkyne and some alkyl halides. You could kind of build up your chain of carbons to start, and then whatever other reactions you need to do from there, you'll be able to do. But we'll see examples of that in the future, so don't worry, it's coming up. All right, so let's look at a summary of all of the reactions from this chapter. All right, and I believe that there's a similar reaction map in your textbook at the end of the chapter. So let's go through some of these reactions, and then I'm going to circle the ones that you need to know the mechanism for. So let's look at kind of the upper right hand side. So I'll label these 1 and, or the upper left hand side, excuse me. So I'll label those 1 and 2. So you'll notice that we have an arrow going from the starting alkyne up to the geminal dihalide. So how would we make that geminal dihalide? Well, we know that if you need to add a halogen across a double bond, you would use something like hydrobromic acid, right? And if you wanted to add 2 halogens to a triple bond, then you're going to need excess HX, where X is a halogen. So that could be HBr or HCl. Okay, so then let's look at the opposite arrow, because there's an arrow going from products 1 and 2 down to the alkyne. So remember at the very beginning of this chapter, we talked about how to prepare alkynes. And you could prepare an alkyne using either a geminal dihalide or a vicinal dihalide. So how do we do that? Which reagents would we need? So we just saw that we could use sodium amide to perform elimination, and then we just follow that up with a weak acid. Oh, my pen stopped working. There we go. All right. So water is a easy weak acid that we could use. Okay, now let's go to the right. Let's look at the product where we have an alkene and then a halogen bonded to the alkene. So how would we go from a triple bond to an alkene with a halogen attached? So we just use one equivalent of HX. So that might be hydrobromic acid or hydrochloric acid, for instance. Okay, and then how would we make a ketone? So that will be product number 4. And it's okay if you want to pause the video and go look up your notes or flashcards. And you can also do this in your spare time too. That's all right. But I do want to circle some of the mechanisms you need to know. So for this one, we would need to use catalytic acid diluted in water, followed by the catalyst mercury sulfate or mercuric sulfate. All right, and then how would we make the aldehyde shown off to the right? Well, we saw that we would need, for instance, 9BBN to start, and then we would add hydrogen peroxide so that it's anti-Markovnikov if you have a terminal alkyne, and sodium hydroxide. Okay, so I am going to skip down to this tetrahalide. How do we make that tetrahalide? So we just add a lot of X2, right? So that could be bromine or chlorine. So we just need excess of our halogen. And then when you're adding this to an alkyne, you also need to use carbon tetrachloride. But if you have an alkene, you just need like hydrobromic acid. Okay, so I'll let you try to fill in the rest of this chart on your own. But the mechanisms you should know are the first one we went over to prepare the alkyne. You'll also need to know how to make the geminal dihalide from an alkyne and what the arrow pushing mechanism looks like. Additionally, you'll need to know the hydrohalogenation reaction, as well as number 6, how to make a tetrahalide. So you'll need to know the mechanism for that one too. So if there's a blue circle, you need to know the mechanism. And I'll try to put together a list of mechanisms that you should know, at least before exam 1. Now, the other thing, though, that you should know is, for instance, when we're making ketones and aldehydes, remember that it first goes through an enol, and then you go through tautomerization to get to the ketone or aldehyde. So just make sure that you know how to draw the tautomerization. Let's see if I can spell this. I did not spell that right. Okay. It's a hard word to spell. Tautomerization. There we go. So for both of those situations, just make sure you know how to draw the enol, ketone, tautomerization, or if it's an aldehyde, how to show that as well. Okay, so one last thing that I encourage you to try is to make a big reaction map. So basically make a map where you show all of the reactions we've learned so far. So for instance, you could show an alkene on one side and just kind of show like how you could make a bunch of different stuff from that alkyne. And then you could show, okay, how do I get from an alkyne to an alkene? And then show all of the different reactions you could make from that alkene. But additionally, you might find some, products over here that can be made into products over on the right-hand side. So kind of see what connections you can make. And what I encourage you to do is just get a big sheet of paper, or just like a piece of printer paper or notebook paper, and just see how many different reactions you can write down and how many connections you can make between all of the different types of products that we've talked about. Now, I'll try to make one of my own and post it on the website so you can kind of see what I'm talking about. But this is a really great way to study as well and just see how much you remember. How many reactions can you recall off the top of your head? All right, so my dog is drinking water very loudly in the background, so I will end the video here, and I will see you all in chapter 10.